Hello everyone, welcome to my channel. Keep exploring. In today's video, we are going to discuss the questions from exercise 1.4 of the chapter Number Systems, class 9. So let's start. The first set of questions says, classify the following numbers as rational or irrational. See the first one, it's given 2 minus root 5. 2 minus root over 5. So we know that the value of root over 5 is something 2.236067 and so on. So we know that root 5 is an irrational number. So the decimal expansion will be non-terminating and non-repeating. So when you subtract, we will get something like minus 0.236067 and so on. So our answer is also a non-terminating and non-repeating decimal expansion. Hence, we can say that 2 minus root 5, whatever the value we have got, is an irrational number. So this will be an irrational number. Next, 3 plus root 23 minus root 23. So here we see that when you simplify the brackets, we get 3 plus root 23 minus root 23. So it gets cancelled and the final answer is 3. So we know that 3 is a rational number. So the overall 3 plus root 23 minus root 23 will be a rational number. So hence we say that the first one is an irrational and the second one is a rational number. The third bit, 2 root 7 by 7 root 7. Here we can easily cancel root 7 and root 7 gets cancelled out. The final answer is 2 by 7 and 2 by 7 is a rational number because it is in the form of P by Q. Next, 1 by root 2. We need to rationalize the denominator. So 1 by root 2. So the rationalizing factor is root 2. We get so root 2 multiplied by root 2 we get 2. So we know the root 2 value is somewhat 1.4142 and so on. It is a non-terminating or non-repeating decimal expansion. Divided by 2 when we do it, we will get 0.7071 and so on. So the answer is also a non-terminating, non-repeating decimal expansion. Hence, it is an irrational number. So it will be an irrational number. The last one, 2 pi. The value of pi, we know it is 3.141 something like that. It keeps on going. So this is also a non-terminating, non-repeating decimal expansion. So when you multiply with that 2, still the answer will remain non-terminating and non-repeating. Hence, the final value 2 pi will be also an irrational number. So in this way we can classify which one is rational and which is an irrational number. Moving on, simplify each of the following expressions. 3 plus root 3 multiplied by 2 plus root. So we know we will be using our distributive property here. So 3 will be multiplied with 2 plus root 2 plus root 3 will be again multiplied with 2 plus root 2. Let's simplify it. So first 3 2s are 6 plus 3 into root 2 we get 3 root 2 plus root 3 into 2 we get 2 root 3 plus root 3 into root 2 we get root 6. So we do not find any like terms here, hence we cannot simplify it further. So this will be our final answer, that is 6 plus 3 root 2 plus 2 root 3 plus root 6. So this will be our final answer. The next one, 3 plus root 3 multiplied by 3 minus root 3. Here we can see we can use the identity, that is a plus b multiplied by a minus b. We get a squared. So a squared minus b squared. So 3 squared becomes 9 and root 3 whole squared becomes 3. So 9 minus 3 we get 6. So we can use the identity here, that is a plus b multiplied a minus b we get a squared minus b squared. Here in place of a we have 3 and in place of b we have root over 3. Next, root 5 plus root 3 whole square. So here we see that it is in the form of a plus b whole squared. So we know that a plus b whole squared is a squared plus b squared plus 2ab. So let's say this. So in place of a we have root 5, in place of b we have root 2. So we get, so a plus b whole squared is a squared plus b squared plus 2ab. So root 5 whole squared is 5, root 2 whole squared is 2, and we multiply, we get root 5 and root 2, we get root 10. Now we can have these like numbers, so 5 plus 2 becomes 7, so 7 plus 2 root 10. The next bit, so you can see here this is in the form a minus b multiplied by a plus b. We get a squared minus b squared, so root 5 a squared minus b root 2 b squared. So a squared minus b squared, 5 minus 2, we are left out with the answer 3. So in this question, just you have to see whether we can follow an identity, and we just follow it according to the identity properties. Next, recall pi is defined as the ratio of the circumference, say c, of a circle to its diameter, say d, that is pi equals to c by d. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? The question says here, pi we are always writing as the circumference by diameter, that's the ratio of the circumference to its diameter. So it is comes in the form of p by q, and we have learnt it that when something is the form of p by q, that is a rational. But we know that pi is irrational. So how we are going to resolve this? So there is actually no contradiction. We have to understand that whenever we measure any length, whenever you are going to measure any length, that is never an exact one. It is never an exact value. So always we get an approximate value of the length. Whenever you are using a ruler or a protractor, any measurement device, that always gives an approximate value. So here when we write p equals to c by d, this answer we don't know whether it is an irrational or rational. So these measurements we don't know whether they are irrational or rational. So hence, when we do not know whether it is we are not confirmed that it is surely a rational, because there is never an exact value. So surely c is irrational or d is irrational, because there is no exact measurement. Hence pi is always taken as an irrational number. Pi is always an irrational number. The thing is, we use pi as 22 by 7. So 22 by 7 is nothing but 3.142857 bar. This is the thing. That means this value is an approximate value. So whatever the value of pi still we are finding, that is very much nearer to this one. That is the reason we have considered this as a value for pi for calculation purpose. Generally we use 3.14. That's the basic thing. 3.14 for calculation, but remember this is an approximate value. This is not an exact value. Same thing, 22 by 7. This is also an approximate value for calculation only. Hence pi is always an irrational number. The next question, rationalize the denominators. Now we have already seen, first we need to find the rationalizing factor. Since the denominator is root 7, we need to multiply by root 7 again. So we are left out with numerator as root 7, and when you multiply the denominators, root 7 into root 7, we get 7. So hence our answer is root 7 by 7. Next, the denominator is 1 by root 7 minus root. The denominator is root 7 minus root 6. So it is in the form of a minus b. So we have to multiply with a plus b to get the rationalizing factor. Hence we get root 7 and root 6 in the numerator divided by root 7 minus root 6 into root 7. That is a minus b into a plus b, a squared minus b squared. That is root 7 plus root 6 whole by root 7 square is 7 minus root 6 square is 6. So we get root 7 plus root 6 by 1. That is nothing but root 7 plus root 6. The last one, 1 by root 5 plus root 2. Same concept. The denominator is in the form of a plus b. So we'll multiply with a minus b. So numerator is left out with root 5 minus root 2. There is nothing to multiply. And the denominator we can write as root 5 whole squared minus root 2 whole squared. Because we have a plus b into a minus b, we get a squared minus b squared, third identity. So we are root 5 minus root t by root 5 whole square is 5, root 2 whole square is 2. So we got root 5 minus root 2 by 3. Similarly, 1 by root 7 minus 2, that is root a minus b form. So you have to multiply with root 7 plus 2. It's a simple logic. If there is minus, you have to use that plus. If there is plus, we have to use minus in this way. So in the numerator we have root 7 plus 2 by same thing, a squared minus b squared. We get in the denominator 7 minus 4, that is root 7 plus 2, 7 minus 4, we get 3. So this is the solutions, the way we rationalize the denominator. So important is just identifying the rationalizing factor, and we can easily get the answer. Thank you for watching. Do like, share and subscribe. Till then, keep exploring.